is actually you have two chart, and you have two chart. Let's see. You have really long chart. Okay. Let's say you have chart here. And the chart here. Okay. And you want to connect those two charts together. And anyway, the speed here, omega here, this size, and omega this side have to be the same. So, we normally use universal joint just for only if you want to connect two charts, very long chart together. And it not reduce speed or increase speed anyway. It just have the same omega. Normally, when you have very long chart, it cannot use normally single chart. Normally, and most of the times when you have long chart, normally you cannot keep lining, alignment. Let's say alignment here. Angle. Let's say this is chart. This chart here. The chart as well. Okay. Normally it's not in this alignment. That's the main thing that we see. In that case, we need to use a universal joint. Okay, it's not said as coupling. Coupling is another one. If you have some sharp and what you connect, if you have some, this coupling also used quite a lot. Coupling. Okay, you have motor. You have motor, you have big load, right? Sometimes we need just diesel load, let's say. Okay, sometimes we have a motor here, have load here, let's say very large load. Okay, and you want to connect this one together. Actually, if you have gear, I know normally sometimes you have gear. You have shaft here as well. You want to connect this shaft together. Also, normally, if this load is quite large, we normally don't connect these two charts together direct. We not normally use direct connect these charts together. Okay? Okay? Because of what? It's sometimes impossible to have alignment. It's impossible sometimes to have alignment. Just small deviation anyway. In that case, we need to use coupling. Coupling. Sometimes this coupling is used to absorb shock vibration, let's say. Sometimes it's used to actually reduce the effect of the misalignment. Also, sometimes you have shock coupling that also reduce some of the shocks vibration as well. Okay? There are many types of coupling. Okay, many types. So you see a lot. If you have motor, pump, connect, we have coupling as well. Right? But in other sense, like universal joint. Okay? Normally, universal joint, you have very long shaft. You will connect these two shaft together and have some angle. Okay? Some angle. If you see the automotive, right? Beneath, you have a shaft and differential gear. Right? You have that one. We use a universal joint. Okay? Okay, so universal joint actually can handle misalignment much more than coupling. Okay? Sometimes you have this angle, this one. This shaft connect with this one. Okay, this one. Yeah, this is universal joint. This one rotate. This one also rotate. Okay. Sometimes this quite larger than this one. Okay. So in that case, you need to use universal joint. Okay. But anyway, to use a universal joint, you have to be careful as well. Okay. Look at this one. We have this is universal joint. This one. Okay. This is universal joint actually. We talk about universal joint. We have this one. This is universal joint. But normally, sometimes when you buy, when you buy, right? It's come up with that like this one. Both of them, both sides. Okay, and you have to tap connect to this one. Okay, you can buy. Okay. Normally we don't build by ourselves because it's too expensive. If you just want to just build just one or two, expensive. Buy cheaper, right? About this size, we just bought yesterday. About this size, let's say 4 centimeter. Cost you 10,000 baht, 1,000 baht only. Not that expensive, okay? But if you want to produce by yourself, expensive, okay? Much more expensive than buying. Okay? Similar to gear as well. Okay, okay. But you have to realize. Look at this one. I have this one, right? We have this one, and we have this one. See? Different between this one, and this one, and look at this one. Okay? Look at this one. You see? Okay? This, the two shaft intersect, right? Intersect. Right? This one intersect. This one is offset. We have offset, something like this one. Offset between what? Angle, axis of rotation of this and axis of rotation of this one. Have some offset. Right? Some offset this one. Okay, so similar to this one offset. There is a problem. You see, look at this one. If I show you how to do this one. Okay, look at this one. Here, show you this one. This one, look at this. Look at this one. It will rotate this one. You see, look at this one. See? There's some delayed angle, see? This one will cause you a lot of problems. This one will cause you a lot of problems. Okay? Because of what? Because of this shaft and this shaft. Too much angle. Okay? The angle are too large. I mean, it's not aligned actually. Okay? That's the problem. Okay? Okay, that's the point. But if you use another type of this one. Let's see. See this also you have some angle here, right? Look at this one. Now no more, you see. See, no problem, you see. Okay? No problem, you see. You see? So that's why that's different if you have offset and non-offset. But in real practice, if you use, if you buy this type of universal joint, sometimes you have to realize that it's impossible to make perfect intersection like this. Normally they have some deviation. Normally, if perfect intersection in that case it costs you more actually. Okay. So anyway, but it's better to have this one. But don't see if you have some misaligned, it means that you have to try to limit this one, the angle of this one. You have to try to limit the angle between this line and this line, right? This sharp and this sharp actually. Okay? This sharp and this sharp. Try to limit. Okay? Don't make it too much different. Okay? Don't try to make it too much. Even though you buy the intersection bar, you have to be careful. I normally limit to 15 degrees. I normally, when they select some of this one, I try to align so that it's not greater than 15 degrees. Some they use 30 degrees, but because normally we buy cheap one, so you have to be careful. Okay, that's the point. Okay, so in this case, if you don't want to have this problem, okay. Sorry, I didn't know anything. Okay, he doesn't want to have this problem. Okay, if you still want to choose this one, you have to make sure that your two axes are aligned. Okay. Otherwise, you have to modify this one so that it will intersect at one point, no offset. Okay, so this problem is you have two choices to do it. Okay, one is to modify this one so that it intersect at same location. I mean, same point. I mean, one point, no offset. Okay, but if you still want to use this one, you have to make sure. I mean, these two lines have to be in the same. These two lines have to be in the same alignment, same alignment. Okay. If you allow this one is too difficult, right? Okay, that's the point. Okay. But if you want to make this one intersect, maybe intersect that same location, maybe you have to reduce the size of this one. One way, if you want to modify this one, you need to reduce the size of this one. Otherwise, they don't fit inside. There's some crash there. Okay, so if you want to modify this one, you have to reduce this one as that one, so that it will be intersect as similar to my case here. this one. See, this one come from the same product. Only I modify that one. Okay, modify that one. So you need to modify this one so that you fit this one. So, okay, okay, that's the main thing. Okay, the objective of this one is we want to tell you how to use universal joints. Okay, what thing that you need to be careful that about the misalignment, okay, of the chart. Okay. 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 So look at this one. Let's say if I do this one for you. Let's say you see this one. You see there is no fix. See, my fix is this one, just these two lines. So you look at this one, my fix this one. Okay, if you look at this one. Okay, I just go there and see what. Okay, this is my fixed one. Let me hide this one. Hide this. Hide this. Hide this. Okay, you see, this is the fixed part. Only this one, just two line. Okay, okay, you can do this one. Okay, this one will be axis of this joint. This one will be axis location of the other joints. Okay, so this is just a fix. Intersect at this one at this point. Actually, this intersect have to be this one. Intersect between this and this. Okay, it's somewhere around here. Okay, it's not this one. Because you see, you have sharp here, sharp here, and this segment with this one. Okay, but if you are modify this one so that it will be no offset, in that case, it's a segment with this one, right? Will be this one. Okay, so you just did this one. Okay, have this one. Okay, so this is my we call it my universal fixed base. Okay, otherwise you can draw as you remember I did for you in the gear mechanism, right? You can draw a part there and aside that's a fix, and you use this joint to actually rotate with that one. This one rotate with that one. That's also possible. Okay. So in this case, I just use my fix here. Okay. Okay. And let's see. See, all the part you can modify it. You just go there. Just go there and at the part B, you just double click and you are in the part design. You see? If you go back to assembly, you just double click this one. Okay? This one. Okay, now we go back to assembly. Okay. Look at this one. We have this one. We go fork ones. The same. Okay. This one. Okay. And this is part is a universal. This one. Okay. Okay. If you still want to use this one, this chart have to be modified. This chart have to be modified so that is aligned. It's aligned. Otherwise, you have crash. Okay. But in this case, just want to show you the angle this one. Okay, so look at this one. We have this one fixed, right? As my part, just pick this one, right? Next, you see this rotation, right? This one, you have, when you design this fixed part, you have to have two parts. I mean two lines actually. Have to have two lines. Okay? Have to have two lines. Let's see. Okay. Have to have two lines. This one. And the other one. This one, two lines. Okay? So the first level, this one with this, let's say this is number one, this is number two, right? So this one had to be number one, and number two had to be level joint, right? Had to be level joint. You need to have control as well. Okay. Level 4 is about fork 2 and you also pick this one, this number 3, let's see, and this number 1, this size, right? So number 3 and number 1 here had to be level as well. Level as well. As well. Okay, 1 and 3, 1 and 2, level as well, right? Okay, let's do revolution joints. I have to assign as well one of these, I mean these universal joints, let's say we have this one, number 4, let's say. Number 4 have to rigid with one piece, okay? See? One of these have to be rigid with one of them. Okay, let's say with the, so both of the input come in here, right? Input will be this way, output will be this way, right? Let's say. So this one, yeah, in this case, you see you have a fork. You see, fork 2, right? This one, fork 2 is this one. This side, right? This one, let's see. Okay, see? So one of them, yeah, this one, number 4 and number 3. 4 and number 3 have to be rigid, connect each other. Okay, okay, and rotation will be this one. Okay, and universal joint will be demonstrate how to rotate this one. Okay, they are asking for this line and the plane here. Then this line of this one and this plane of this one, line and plane have to be same. Okay, okay, so that's the point. I would like you to try it yourself. Spend time at least 20 minutes. Try it. If you don't understand it, right? Look at the okay. So look at this one. You see, level joint. This one is big, right? This one is this one, right? Okay. You see, you have to have angle as well, right? This joint. Right? So you have control joy as well, right? Okay. The other one, this one, with this one, okay? This one, you see, level joy as well. Have to be command as well. Okay? This one with this line, right? Of the fixed plane. Okay? And level joy as well. How to assign object. Okay? You can use plane anyway. You see inside you can have plane here. Yeah, some of this plane. to do assign the offset, this one. Okay, so this one is for this one. Okay, so this one and this joint, this one and this joint, right? And look at rigid here. See this one and this one will be rigid. After you assembly, you just rigid. Yeah, if in the location, exact location, you just rigid. Okay, that's the point. Okay. Okay. So universal joints, you see, because as I mentioned, the angular velocity both sides will be the same. The angular will be the same. So no compound, no K ratio. Okay? Okay, you have to tell the axis in rotation. Axis and rotation. Plane rotation, right? This one, right? Okay. So look at this one. You see, we have the axis. We use point. We use point. Let's say you see this one. We have point, right? This point belong to one. The other point belong to the other one. See? So when you create that fox part, you have half point at this section, right? So that point will be used to connect. Okay, so if you want to use this one, the point has to be there. So this one has to have point at the intersection here, right? See, this one, that one, right? But the point should be this one. So this point belongs to this one. This chart also have this part, right? I mean, this part also have this one. Because both of them are the same, right? So you just create one only, right? And at point, you have to find out the intersect. I mean, the intersect of the chart here. Okay? Create that point there. Okay? So, in this case, see, point belong to this shaft and the other point belong to this shaft. Okay? Okay? And consider this one, edge. This one, rotation. Rotation. You see? Okay? I put this rotation at the intersection because we try to rotate based on that one. Okay? And plane has to be in the same alignment with this one. Okay? See plane. You see, this one is the axis of rotation. This one. See, you have to draw this line parallel to this one actually. Okay? And plane. This one belong to this one, right? And plane, this plane belong to this one. This plane belong to this one. Okay? This shaft belong to that one. See? This shaft belong to that one because you want to rotate it, right? And this one because you input and go. Where you will look at that in this plane. This one. Okay? This one. Because your input will be here. And that one will be rotated. Okay? So that's the way you design your universal joint. Okay? Okay? Try it anyway. You learn a lot anyway because you learn mechanism as well in this case. Okay? Okay, so either way, if you want to maintain this one, it means that angle here and angle here have to be aligned. Now we have some angle here, right? This one and this one. have angle. If you have this angle, you're gonna have crash in that case. You rotate out of the center. Okay? Okay. You can reduce this one to just one degree. Maybe it's okay. You use sounds. Yeah, if for real, you sound. For real, I mean for real application. If you have something that lies, it will use the opposite. And you use that one, and you maintain 1 degree, let's say. You have some hertz of sound. Okay? Okay. Doesn't mean there's a problem with this one. For a while, this one will be born now. Okay? Okay, let's try with yourself. So in case, as I mentioned, in case you have long shaft and you want to connect those two shafts together, if you cannot align this one, you have to use this type instead. And use this type instead. This one instead. When you buy, you see some of this. All the commercial one is like this. Okay, this one is normally is for like you have huge big one, and this one is actually easier to create. You should have big one, right? You just what weld together big one. You just get this shaft and weld together. Right? That's why you have big one. But if you buy Jinko, universal shaft, it not have just the same. No opposite. Okay? Okay. That's for wrap up the assembly design. Okay? Okay. Next topic. Okay, you just try to do, I don't know, you just spend some time to learn how to use one. Okay. This one, for example, this one as well. You see, this some universal joints. You see. You rotate this one. You see? Okay. Sometimes if you want to look at this one as the level joint, let's see, if you have this one, you have angle here, right? Let's say this one, and you have angle here. You angle as a control, right? You can if you use the button mount here, you can change step. How active? You look at this one. Let's see. Look at this one, right? When you move this one, Sometimes it's not smooth. Right? In that case, you can reduce or increase as well. Okay, the accuracy of the rotation, right? This one. By just go back to the revolution joint and for this one, right? And you have this one angle, right? This is the control, right? Use the button mount, you have changed steps. 1 degree, 0.5, 2 degree, 4 degree. You can try it. You can move, see how it's moved. Right? That's one. All the control, you can adjust step shift. All the control. Not driving, because driving you can control the step. Okay? Okay. That's another point. Let's see. Okay. Okay. Let's see. Okay. Sometimes I have this one. This is all exercise. Let's see. This is all exercise anyway. Okay. This is what we call leveling device. Okay. The point I would like to mention is look at this one. You have this one, right? The whole below here as well. This one is normally if you want to lift something, lift some heavy stuff to make it leveling, right? Okay. The heavy stuff we place on the top of this one. Okay. You can rotate this one, move up and down, right? Look at this one. Look at this one. Let's see if I do this one. Okay. There's only one, this one. Okay. You see? We rotate this one. This one move up and down, right? You get two order here actually. You get very heavy stuff here. Okay. Look at this one. You have this center. This center also aligned with this center, right? Look at this one. See, center will be aligned. So that you see the center will be aligned. See. Okay. So that this one just only up and down. Okay, maintain that one. The reason that I want you to know this one is, let's see, you have this one, right? You have, okay, this is part number one. This number two. Okay. This number three. This number four. This number five. Okay? So look at this one, you see? This one, number one, and number two. Number one and number two should be prismatic gyro. Okay, actually in the slide presentation also I have this example. Okay. Number one actually because this number one is fixed actually. Number one is fixed. Okay. Number two. So number one and two. Number two will be moving this one. Right. Okay. Number two. Right. Okay. Next, look at this one. You have this number three and number two. Number three and number two also. Number two and number three also prismatic gyro. You have inclined plane here. Inclined plane. Right? Let's say it is a fix because this one hit the wall here, right? So it's not like a fix, right? After that, right? So you move this one. This one with this one's sliding, right? And it's prismatic. This one and this one also is direction, right? Okay? Okay. Okay? But look at this one. You have this one, number two and number three. Sorry. Number two and number one. Number two, this number three, number three number 3 and number 1 have to be another, we call this one, look at this one, you see? This one, this part, let's say, let me put this one. Okay. This one, and this one, actually, what? Look at this one and this one. The center had to be aligned, right? This one and all this one had to be aligned. So that you fix this one with this one, right? Okay? That one had to be aligned. So in this case, you have 3 and 1, right? 3 and 1, 3 and 1, right? This one. Right? 3 and 1, 3 and 1, and also 3 and 2, 3 and 2 as well, you see? So this one connected to this one, connected to this one. Right? So you have to be careful. You cannot assign this one all together, because joint is connect only to link. Okay? I saw some mistake I described in the old days. This one to be exam. Okay, but no more. Don't worry. No more. Okay. Okay. Look at this one. Okay. Actually, I use this one. Actually, this command is free. We can move some of these. Right? We can move. I don't use this one much, that much, because this one equivalent to you put this one attached to the part and move. Okay, similar, right? Now I use this one. It's a free. Just select and move, right? Okay, but it's similar to this one. Attached to that one and move, right? Similar. Only this one, if you move this compass, fix to the part with constraint, they apply that constraint. Okay? But if you use this one free, no constraint. Even though you just satisfy constraint, right? You just override constraint, just move it. Okay? Like this one, okay? Okay, so if you say, oh, okay. Come back this one. Back to this one. Okay. Okay. Right. And this one, in this case, you have number 3 and number 2. Let's say number 3 is. Sorry, this one just missed this one. I have to move a little bit this one. I have to move it a little bit so that I can use that right here. Okay. Yeah, number 3 is, and number 1 here have to have some what? Align. Right? Center align. And if we change to cylindrical, we change to cylindrical. So this one, see? And also can be rotate, this one. Okay, but anyway, if you fix this one, the rotation will not affect, right? We just select this one and the bottom one as well, okay? The other thing is number 4 and number 3 to do simulation. Sometimes number 3 and number 4 have to be fixed, but in real life, in real application, it's not fixed. Can right? But if you want to just do simulation, you just make fix. That's all. maybe fixed. Just for simulation, just go move. But in real life, it's can be moved this way. Otherwise, if you don't fix this one, you said coincidentally two phase, you're gonna have another three input, right? Need to make your degree freedom 0. Okay? Or you can allow without degree freedom not 0. That's also possible. Okay? But you have to realize that the degree freedom will not be 0 in that case. Okay? Okay. That's another thing that I would like to mention. Okay? You want to try this one also possible. I can place the dimension this one into the crossfield. Okay? It's a very good exercise anyway. Okay, so look at this one. You see, we just rotate this one. So this one is an input. Okay? So in this case, this choice, and this choice have to be what? Semicolon, screw joint. Have to be screw joint. Okay? This one. Okay? This one. Okay. This one and this one is screw joint. Okay. This knot and this one is screw joint. So that if you move this one, just rotate this one, right? Rotate this one will move this one. Okay. Okay, that I think enough for assembly and mechanical system design. Okay. Next topic. Next topic will be surface modeling. Okay. Okay. Next topic. Anyway. Surface modeling. Okay. Actually, you have art design, right? Art design. That one is a solid modeling. Solid modeling. Right. You have assembly design. Assembly design, right? That sometimes we call product design. Product design, right? Okay. And the third one we have surface modeling skills. Okay. Surface modeling actually they have basics. Basic surface modeling technique and advanced surface modeling technique. Advanced, basic and advanced. And the other one for CATIA, I set I set this name by myself, not by CATIA. Because intermediate. Intermediate modeling technique. Okay. Look at this one. You see, intermediate and advanced. Sometimes we call advanced. This one is a free form. Free form. Okay. So look at this one. I show you. Okay. There are three of them. Look at this one. If you are looking this. Okay. Okay, surface modeling anyway, this one. Okay, actually, you have this. Okay, this like a surface modeling. You see all this. You see, this one is surface modeling. Some of this one as well. Some of this one as well. This one. Okay. This one as well. Surface modeling. This one can also. You see, this one you have to curve. This one. I mean, this surface as well. There are some many of them. Also, this is a surface modeling as well. Okay. Okay. So look at this one. Okay. This is a cavity design anyway. Okay. In automotive, we call it class A surface, class A and class B. Okay, for automotive design, automotive only. If you are not automotive, then I think it's better to know as well. When we have automotive design, there are two types of surface. One is class A, the other one class B. What do you mean by class A? Class A is the outside body, you see. All this is class A. All this is class A. Right? Class A. Okay, for automotive, right? Otherwise, beside from A, we call class B. Other side, but its body design, we call class A. That's for automotive. Okay, and look at this one. This is very advanced surface design. Okay, we normally use we can use intermediate level as well as advanced levels. But for basic, we're gonna use for this one. Okay, this one maybe we can use basic. This one no. Yeah, some of this. This one as well. Yeah, that one as well. Okay. So look at this one. You see, we have free-form surface design, right? Free-form surface design, and advanced. It's very advanced. I mean, free-form. It means free-form like you have a lot of freedom to modify the surface. Right? Okay, one character of this one. You see, this one is not consist of. This one is not consist of single surface. It consists of many surface. Many surface are patched together. Many surface are patched together. How to make those surfaces connect so that you got very smooth surface. That's the point. Okay. When I ask you in the exam, that we don't have. Yeah, the automotive they have. Okay. So you have this other patch here, and how to connect those patches together. Say this one and this one on surface, this one and this one is on another surface. You see, how to connect those surfaces together so you have very smooth that one. That's a very difficult one anyway. Okay, so we have free form is like that. You have very freedom to modify the surface. Class A and Class B, this one is for, as I mentioned, for automotive only. Okay, we call automotive only, correct? Application only, right? Class A is for outside body, inside. Otherwise, from body design is a Class B. Okay. You have to understand curve because complex surface normally come from complex curve. So normally you need to create complex curve if you want to create complex surface. You have to. It's not like a feature, right? It's not. In this case, you need to try to get profile curve. Complex curve in this case, I mean not just 2D, 3D curves. Okay, how to obtain 3D curve? That's difficult. Okay, so because surface come from curve, so you need to understand how to create curve. You see, create and modify curve. You see, create as well understand curve and create and modify curve. Actually, there are many types. Two types of curve. Two types of surface. Two types of surface. Okay. Come from curve. So to understand curve, so that you can create these two types of surface. Bezier and spine curve. Okay. Character of surface patch. You see how you connect two surface together, so that it's very smooth. Very smooth. Generally free form and that was surface, you see, because we don't in this class we don't gonna cover much about free form. But free form means that you have freedom. They have a control point. Actually, you get curve here, surface here. You have control point, this control point. If you modify this control point, the surface will be modified as well. See, this they call what this one, free form and derived surface, right? Modified surface. Okay, modified surface. Application of surface. That many. I can tell you if you are really work in product design or you are really love in engineering design, definitely you will have to use surface. Definitely, you have to use surface. Solid is just simple, right? Very simple. Solid is just inside. Outside will be surface. Okay. Look at this one, you see. Free form, you see, free form. But anyway, some of the free form surface, we can use intermediates as well. Intermediate as well. Okay, module as well. Look at this one. Look at this one. If you have this, you see, there are some of this one. As I mentioned, right, we have basic. We have intermediate. Medium. We have advanced. Right? Okay. So look at this one. Basic is this one. Generative, wireframe, and surface modeling. Generative, wireframe, and surface modeling. This one. You consider this one as the basics. Okay? This one is basic. Generative, wireframe, and surface, right? For intermediate, in this case, is this one. Okay? Generative, shape design. Okay? This one, if you buy basic art design, this one will be given for free. Okay? If you buy that here, this if you buy art design, this one, or assembly design, they give you free. This one. Normally, if you use SolidWorks, you use Inventor, you use SolidWorks, Solid Edge. Surface is about this side there. Okay. But if you want better surface for here, you have to buy some software, big software. For example, this here, also an X from cement. That also they give you surface design as well. So this one you have to pay extra. You want this one, you have to pay extra. Okay? If you pay extra on surface, you get this one as well as you some of this freestyle, right? Shape design, this one, right? This one we call extra for freeform surface design. Okay, you have control point, you look at this one, see control point, and you can modify control point, the surface will be modified as well. Okay? But we're not going to cover this one. You can check your quality of the surface as well. Quality of surface. We cover just only this one. I cover just only this one. Just only this one. Because every command here you have inside here. This module has every command here and also extra. Okay, so I think this one is just enough. I think enough for you to do your work or your project or whatever. Okay, that's enough. Should be much more than enough. Anyway. Okay, so that's the point. Okay, so look at this one. You see, free form. Those objects that cannot be represented by solid primitive, right? Normally we use preform surface or intermediate surface design. We can say this one, generative shape design. Shape design is okay. It's good enough anyway. And freestyle, freeform. Category called freestyle, free shape, free form, whatever. But we are cover this one. It's good enough, you see. So those objects that cannot be represented by solid, by part design, you have to use generative shape design. Okay. Most of them is normally outside enclosure. In design where aesthetics play, program so play vital role on shape definition. Outside normally, you see, outside to look in place. How Mao designed this one, for example, this one. Okay, this one, very simple surface. It's cost actually sometimes main component of this one and this one are about the same. Only there's some better electronic. But look at this one. This one cost you only 300 baht. Right? You make better one, better out fit to your. This one cost you 2,000. Right? And you have another one, big one with very ergonomics to it. The new one just come out about 4,000 baht. See, actually inside is about the same as this one, but we design very good for your ergonomics. Yeah, this one, it costs more. In that case, you need some of these surface design. Okay. Okay, widely used in automotive as well as aerospace and industrial design. Industrial design, how to make it look good, how to make ergonomics design. And also complex. Learning curve of surface design. Learning curve of surface design is not as fast as solid modeling. Solid modeling very easy. Normally when we train surface design, let's say for typical surface design, solid modeling, you can learn within 1 week. 5 days. 5 days, whole days. If you learn 5 days, whole day, you can expert in solid modeling. But surface modeling, no. At least 1 month. 2 weeks for study the concept. Another 2 weeks or 4 weeks for gain your experience, gain your skill. Right? So most of you are dying. trying to in just 1 week. And you know, the exam will be cover most of the problem of the cover surface model. Solid it's just very easy เป็นการดูถูกเกินไป so it will be surface modeling most of it okay and assembly as well. You learn about 2 weeks, right? Assembly, if you have to send an engineer, you can learn within 3 or 4 days anyway. So let's just see how the command, how to set the command. That's all. But anyway, you have to have some engineering linkage background first, right? That's the main thing. If you study assembly like a technician, design based on dimension, that's easy. But in real life, no, not that. Okay. You see, this surface. You see, we do have some capability of how to check quality of the surface. This one, you see, quality of surface. This is some tools that used to see, to observe the quality of the surface. This spectrum, this strip. Yeah, if this strip is very parallel, very smooth, it means that your surface very smooth as well. This one is about low curvature. If curvature is smooth, this one we call quality of the surface very good anyway, very smooth. So we have some of these to check the quality of the surface as well. Okay. Okay. See, class A is about body design. Anyway, you can check. You see, you have to have very good anyway, smooth surface. Okay, this some part. You know, this is a project. Your I mean, 10, 15 years ago project. This one, everybody had to finish project like this. But now no more, because this time student you don't have patience now you may ask but do nothing. Okay, in the old days no ask, no question, just go for it. That's the point. That's a different point. Gen this what this gen Gen Z, that one you got baby boomer and what another baby what Gen A, like that baby boomer Gen no baby boomer and X, right? X, Y, Z, right? Okay, this is Gen X and Gen Y. In the old days, it's very easy to teach anyway. If you learn, if you want to learn a lot, I can give you a lot. Stuff anyway. Okay. Understand curve as I mentioned. You see, surface is based on what curve? On curve, 3D curve actually. Look at this one. You see, you have curve as well. You see. Look at this one. See. You see, if you want to create this one, you see this one, you can see, especially this one. You need to have curve, and use that curve to actually create surface. You learn workshop anyway. Okay. Okay, inside this one, there's a lot curve, right? Curve is a line, right? Right, it's an equation, right? We don't use this type of equation. This is the equation that you normally use in typical mathematics, typical engineer. But in CAD system, this one we call non-parametric curve equation. But in CAD, we use another one. We use because this non-parametric, right? This one we call parametric curve equation. Parametric curve equation. For example, you have this line, straight line, right? This one you have y over. Let's say you have x and y, right? And y equal to ax plus b, right? This one, right? A is the slope, right? B intersect, right? In this case, this one cannot be used in CAD. Okay, we use another type of equation. Let's say if you have this one, you know point, right? You know point, right? So you can have this one. Every point in this one, every point along this one is we call U, right? U is start from 0 to 1, right? U, if U equal to 0, it means start point. If U equal to 1, it means end point, right? Any points along this curve can be written this one, right? PO plus U multiplied by vector of this one. This is we call parametric curve equation. Parametric curve equation. So the point that I would like to make is this one, U, right? Start from 0 to 1. Sometimes you draw a curve and you want to assign a point there inside the curve. Okay? Sometimes some option come up with this U. How sometimes percent is equal to percent. Okay? You can assign point along this curve by assign U instead, which normally non-parametric curve cannot do. Okay? So most of the curves like this one. Okay? Just give you some ideas only. Okay? And you see, all CAD, you see, we don't use this one. We use parametric curve equation instead. There are a big book about mathematics of non-parametric curve equation. But anyway, just give you an idea. 0 to 1, right? Parametric variable, right? 0 to 1. This one. So this is equation. Okay? Look at this one. Something like this one. Equation. X and Y. In that case, T is a parametric variable. Okay? This one. Okay? So you can get this one by this equation. So this one is equation, then this one. No x, y, no coordinates. Just use parametric curve equation. Okay? Okay. Just give you idea. Anyway. Okay. So you have point, this one, point 1, point 3, point 4, point 5. 1, 2, 3, 4, right? This one we create this one. Okay, BCA curve. See, this BCA curve. Okay, if you modify P, you have different curve. Okay? If you modify P curve, P actually is a control point. As I mentioned, if you are using free body, free style surface design, you have control point, you can modify that one. You can modify this. And the curve will be modified. That's what we call free form, free style. But in general cases, we can, but not as free as free size surface. Okay? Sometimes you need to understand degree of curve as well. Degree of curve. So sometimes you see degree of curve. You have 3.1, 0.0, 0.1, 0.2, right? Degree of curve is degree of curve, right? So this is 3 point. Degree of curve equal to degree of curve. This one equal to number of point minus 1. Okay, degree of curve equal to number of point minus 1. Okay, that's the degree of curve. Okay, if you have, look at this one. You have this one. Okay, this one is a 3D curve. Right, this one 2D curve. This one. Or this one a 2D curve. Okay, this one 6D curve. Right, we have 7 points, so we have 6-degree curve. If you split this one, okay, if you split this one, okay, there's a lecture, PowerPoint lecture is called creating surface. It's called this one. Okay, if you split this one, make this one to curve, right? In that case, sometimes we split, sometimes if you drill with this degree of curve, it takes a lot of computer time as well. But sometimes you can split this one. It means if you split the curve, you have some continuity effect now. See, it's not actually smooth. If you split this one, they have connectivity level G0, G1, G2, G3, sometimes G4, G5. Smooth, right? In this criteria, we support G0, G1, and G2 only. This one, that's good enough. Okay, what is mean by G0, G1, G2? I tell you. Okay. Okay. Look at this one. Let's say this is the spike curve. This is a spike curve, right? This is a spike curve. Okay. EPC curve. You have control point here. Control point here. Control point here. And control point here. That's a PCA. You see? But this is a spike curve. Right? Spike curve. Control point is on the curve. PCA curve, no, not necessary. Okay, but I will give you more detail on this one. Look at this one. You see, you have this spike curve. Okay, if you modify control point, you see, you have this one, right? As you know, right? If you modify control point, you can add point. It means that you can add in your curve, right? This one, right? You've got control point, right? Okay, you can add, you can delete. That it means that you can change degree of curve, right? Okay, look at this one. Okay, now, okay, specify coordinate control point, degree of curve. You see this degree of curve. This means that you can split this one. Let's say, let me go to this one. Okay, look at this one. I said PC and B spine, right? Look at this one. The whole. You see, B spine consists of multiple BC curve, right? B spine consists of multiple BC curve. So we can have this one B spine consists of many DP point, right? And the control point is along this one, B spine. This one. Okay, so if this one is a B spine, let's say, and this one is B spine as well, right? So sorry, if this one is a BCM and this one is BCM, you connect this one together, we call this B spine. This B spine. Okay? Okay, so connect between this point, you can assign connectivity, degree of connectivity. For example, let's say if you look at this one, position continuity, this one is called position continuity. This BCR connect by this one because this is connection point, right? End point of the green one and start point of the purple one is at the same location. In this case, we call position continuity. Okay, tangential continuity means that this tangent, and this tangent at this connection point are equal, are the same, right? We call tangential continuity. Okay, this one we call G0. If you see in sometimes they ask you for this is your G0, this G1. The other one, curve wedge continuity, G2. Right, curve wedge continuity means that, look at this one, if you have, let's see, if you have one curve here and another curve here, okay, if this G2 curve is mean that this curvature and this curvature on the other side have to be very smooth. Look at this one. What do you mean by smooth? This one not smooth. See this one. Okay. Curvature equal to 1 over R. R equal to radius of curve. Curvature is 1 over R. Okay, so this one, you see, this means that this one is not continuous. You see, so the quality of the curve is not satisfied G2. No G2, right? This one. Okay, this one as well. Okay. So look at this one. Let me show you this one. Let's see. I have this curve. Alright? And I want to make fillet here. I want to do fillet here. Okay? Look at this one. Look at this one. This one is, you see, you have fillet, right? Fillet, this one is a G1, right? This is a G1, right? G1. I need G1. Right? If you cut this one out, okay? See, you maintain tangential continuity, right? Maintain G1, right? If we cut this one, trim this one, and trim this one, and we use this curve, if we use this curve to create surface, what happened to this one? Look at this. Let's use a pad. See, look at this one. It's not that smooth actually. Look at this one. There are some some of this one. Look at this. You see some here, as well as some here. Okay. Not that smooth. It's just tangential. This is G1. If you are using this one for very smooth surface, no. So that's why when you want to very smooth surface, fillet or potentiality is G1 only. And sometimes it's unacceptable. Okay, you have to be careful as well. Okay. Okay. So look at this one. See, you have this one. See? See, it's not that smooth. You see, you have something. See, this one. For carbon design, this one not unacceptable. Okay. Okay. And you can check by using radius of curvature. Low. You have this one. Or you can check. You can display curve radius of curve. This one are the same, but this one you see. But detail inside, I mean, by using radius of curvature is more detailed. Actually, this one. See, if a good one, you have these have to be very smooth. If good surface, this one has to be very smooth. Actually, something like this one. If good one, this one will be this one. If this connection, you have this curvature, this one, like this one. Okay? Okay, this one, and this one, you see? That one is good. That means smooth curvature, radius of curvature. This one is not smooth anymore. Okay? Okay, I don't want to go to relational curve. Actually, relational curve is a curve that's used in most of the cats. Cat use relational curve based on what? Parametric curve equation. Okay? See. Okay. So next, the concept when you want to create curve, I mean surface. Normally, you need to create surface. First of all, you need 3D point. Point. 3D point. Right? From those points, we can create complex curve. Complex curve. Okay? From complex curve, we can generate complex surface. That's a typical process. You see, the more if you can get 3D points, the rest is not that difficult, very easy. Okay, okay, because if you can get point, you can get complex surface, and you can modify that complex surface, modify or edit surface, so that you can get complex surface. That's the point. Okay, when you do part design, normally point is just 2D point, right? Because you start in plane, right? That's 2D. But for complex, no. I mean for surface, point has to be in 3D. 3Ds. To assign point in 3D is not that easy. Not that easy. Because you see you are working on 3D software, right? But your screen only 2D. Right? Your screen only 2D. So you assign point on 2D screen very, very difficult. Right? Okay? They try to use VR, virtual reality. You see, and you can select point. That one started 20 years ago. Now, still, it can use for game, but you cannot use for really precise. Right? In manufacturing, no. In game, it's okay. Right? But for manufacturing, for engineering, you need precise location. Right? So user grasps not gonna work. Okay, they have something else. They have something else. They have now they develop some device that can assign point and then measure point, capture point, right? Okay, I will show you. See, free form surface may need compact curve, right? This one needs compact curve, right? Compact curve may be created from data point. Data point, you see this one, right? Data point can be obtained from sketch. It's impossible. For simple ones, okay. Okay. And for some like generative design, yes, you can assign point for 2D and you can assign for 3D as well. Okay. Okay. Miniature model is means that you have, if you want to create mouse here, means that you need to have what? Mold. I mean not mold. You have to have clay model. You have to have clay model. Use clay and make a model. And that one we use as a template to measure point. Right? That's one. Okay. So this is that one. Okay. You have miniature model, and you use some device to measure point on the surface, right? And all mathematical equation. This one sometimes you use for wing, aerospace wing. One cross section, that one for mathematical. That one. You can also this one. Or can be digitized from full size crane model. Digitized from full size free model. Right? Let me show you. Okay. First of all, I show you some of these one. You see. We have CMM. We can modify CMM to use as a device to capture 3D data point. CMM stands for coordinate measuring machine. Okay. For example, look at this one. Okay, you have this one. Look at this one. You see, you have this image. This is a model. You have point there, and you use mouse, something like that, to capture point. Right? This one. Okay. For simple ones, okay. Because some of the factory they do have CMM. They do have CMM already. You can modify the CMM so that you can use it for 3D capture. Okay, that's one. Okay. The other one is this one. This one we develop our machine itself by ourselves. Use laser. See, laser capture point. Okay. So this is a laser. You just move this one and you capture point. Okay. Yeah, this one. This one. After the time, the new model. This one. Instead of laser, point laser, we use camera and live laser. You see, we built this one about 24 years ago. This one. Okay, we can capture this. You see this one, we can capture point along this. Okay, that's we call CMM. Okay, and point can be input into. We don't have this one. That's okay. Okay. So after we have point there, okay. After we have point, This point can be used to, you need the filter, and this is a filtering version. And this one is used to create surfaces. Okay, similar to this one. So that's the way. That's the way. We do have a package called this capture model. We do have in this setting as well. But you don't have device here. You need some device. Okay. Okay. This one. You see, you have car. This point from device, and this car can be integrated here. This one, and we can use filtering. You have this one, and you have this line. This one, you can actually use this one to create surface. Okay, I don't want to go into detail this one. Okay. 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 I think that's about introduction of the surface model. Okay, now I tell you how to use the generative shape design. Okay, look at this one. You see, if it starts generative shape design here. Okay. Today, we need to submit this work. Okay. It's a must anyway. You have to submit this one. Okay, as well as this one. This one. Okay, we need to submit these 2 days anyway. Okay. The main point of this one is, look at this one. The more difficult one is this. Look at this one. But anyway, I will show you the command anyway. Look at this one. You have this curve, right? This is a cross section. This one. See, you have curve here. See, curve here. This one. Okay. You have curve here. You have curve here. This one. This one. Right. See this curve, as well as look at this one. In this one, look at this one as well. Okay, this one, this is this cross section. see? And this one is this one and this one. This one is curve. As well as this curve. Right? This one is on top. Okay? Okay? And the top view, you have this one, as well as this one, and this one, right? This curve, right? So you need to create some of this curve if you want to create this surface. Okay? Okay, that's the point. This one, for this one, you need multi-section here. You want to create this one. This one cannot be created by using surface, model. You have to use surface modeling. The less you can create by solid model. Okay? Okay. Okay, I just show you first. Let's see. Now, I will train you how to do surface. One is based on, the first method is based on solid modeling technique. Similar to solid modeling technique. Okay. The other one is mainly for surface modeling. Surface commands specific. Okay. So first of all, start with technique similar to solid modeling first. Okay. So first of all, let me use this one. You see, generative shape design here. We don't use generative wireframe. We just use generative shape design. Okay. Actually, generative shape design and part design are very similar. They use the same file format. Okay. Let me create this one first. Okay. So look at this one. It's like this one. You see this generative shape design. See on top this one. Okay. Now look at this one. You see you have, let's see, you have pad in solid, right? You have pad. Right? You have pad. You have pocket. Right? You have what? Shaft, right? Roof. Right? You have what? Multi-section, right? Section. You have grid. Stiffener, whatever. So anyway, look at this one. We have, if you are in generative surface design, you have this one. You see, this one equal to this one we call extrude. Extrude is equivalent to pad. Okay, but much more. You see, this one revolve equivalent to char. You have multi-section, this one, right? Sorry, you have ribs, right? Ribs. This one is ribs. This was sweep. Multi-section, this chart from revolve. Right? See, you have field. This one, field command, is mainly for surface design. Okay? Okay. So the difference between, you see, you don't have pocket here, we don't have groove here. No. Okay. The difference between this is like to do pad. To do solid modeling. The curve, profile has to be close. Right? Have to be close profile, right? Remember? Close profile, right? But in surface, no need. Profile can be open. Okay? Surface it mean if you put thickness is equal to solid. See, surface into put thickness is equal to solid. Okay, and also you have to remember you have solid. You remember that I already trained you, right? How to extract surface from solid, right? Remember this one, right? See, so you can use this one as well. You see, surface can convert to solid. You can extract surface from solid as well. Okay, vice versa. Okay. Okay. Now let's see. Let's see. If I want to show you how to do extrude, let's see if I draw a curve on a plane. Let's see. Let's try this one. Okay. Let me try this one. Okay. Okay. If I draw a curve, any curve. See. See. It doesn't have to be. No need to cross. No need to close. This is a spine curve. You can add point, you can delete point. You look at this one. You see? Okay. You see, this is a spine curve. Open, right? If you want to create surface from this one, extrude this one. Extrude. Select this profile. I select this profile, and can extrude. Similar to that, right? This one. See? Okay. Now we have surface. Okay. If I want to change to solid, if I add thickness, it will convert it to solid. How to change to solid anyway. Now you are in generative design, right? If you want to obtain solid from this one, it means that you need to assign what thickness, right? So I have to go back to part design. Go back to part design. Okay, now we are in part design. Okay, look at this one. This one is extrude this one, right? This is sketch. Okay, so if I add thickness, this one, this command thickness. See? Thickness surface, you see? Now we are in part design, you see? Thickness, this one. Thickness, right? Which one I want to have this one, right? You can have direction. First direction, this one. Second direction, this one. You can reverse direction, this one, right? How many? Let's say I said 2 millimeter. 2 millimeter. Okay, boom. Now you have solid here. You see, if you hide surface, now it's like a solid. See? Okay, if you show surface, this one, right? See? Let's see. Okay, if I delete this one, okay, I delete this one. Now, you see, have this one. If you want to go back to surface, we just change design, right? Go back to surface. Now we are in surface model. Okay. If I add line to this one and this one. Okay, 3D line. You have in surface, right? 3D line here, line. Point to point, right? Point to point. I select this point. Right? See line, point to point. Okay, so we have this one. I add this point as well. This point, and this point. Okay? Okay. Now, you see, I have this curve. This curve and this curve is combined to have cross surface, right? This one cross surface, right? Cross surface, right? So that we can create surface from this cross surface. If it's not cross, we cannot create. Because it's a cross surface, right? So we can create surface from this one. How to create surface from this one? We use fill command here. Fill. Okay, fill. Okay, look at this one, see, outer boundary, this one, just select this one, select this one, and select this one, okay? Now it's close, right, this one, okay. Now you have this surface, you see, surface, okay? Next, I can give another few here as well. Fill this one and this one, right? Okay, we have this one. Okay. I want to get another one surface at the bottom as this one. Okay, I can fill as well. Fill. Select this curve, select this curve, select this curve, and select this curve to form cross surface, right? Okay, like this one. Now, this one consists of, you see, this surface, this surface, this surface, and the bottom surface, right? This one is formed like a closed volume, right? Closed volume. So in that case, we can convert this one into solid. You can convert it into solid. But you have to join all those four surfaces to be one surface, one closed surface. Then it need to be joined, right? Now it's export is split now. You need to join them together before you want to convert it into solid. Okay? How to join this one? You have this command join, right? This join. See? This one, join. Join can be used, join surface, join curve. No, join point, no. Join surface, join curve. You can use. Okay? You have curve, different curve. You want to join them to be one curve, also possible, right? You can split it as well. You don't know how to split at the moment. But this one can be joined. If you join them and you change the connectivity, also the real curve will change. Okay? So let's say now you need to join this surface together first, right? Okay, join. Select all those surfaces. You can select from this one or you can select from this as well. This one, okay? Four of them. Okay? Boom. Now everything join, right? This one join, right? This one. If you want to convert that one into solid, okay, you have to go back to solid again. Go back to solid. Bar design, right? And now you have, previously you have thickness, right? Now you have cross surface here. Okay, previous thickness is cross surface, right? Okay, cross, which one? Select this one. Boom, okay. Now it's convert to cross surface this one. If I high join, now it's solid, you see? Okay? And you can do it like a solid anyway. Okay? Okay, so this simple example anyway. Okay, so you can what? Change from surface to solid as well as you can extract surface from solid as well. Okay? Okay. Let me close this one. Let me delete this one. I don't want. Okay? I don't want this one. This sure. Let me delete this one. Okay? Let me delete all this. Okay? Let me delete all this. Let me have this one. Okay? You have another thing, you see, you have, let's go back to surface design, go back to generative shape design. Okay, generative shape design here, right? Next, look at this one. You have some point, let's see. Okay. You can have, look at this one. First of all, you have this one, offset surface. You see, offset, right? If you want to offset this one, offset this one. Okay, how the distance, you can put the distance, okay? Offset distance, okay, boom, you have offset this one, see? This offset, anyway, okay? The rest, okay. Let me delete this one offset. Now, another one that we use a lot, let's say if I create a plane on top of this one, I create plane. Okay, just on top of this one. Okay? Okay, I just draw a surface. Okay, let's draw a curve. I use this one, select this one, choose this plane. Okay. Okay. Let me draw a curve here, spike curve. Close this one, see, on top this one. Okay. I can project this one onto this surface. Okay, I can project this curve onto this surface. Okay. See, there are two ways. There are two options. Projection is this one. This command. Okay, projection. Projection, this one, projection, there are two options, you see, normal and what? Along the direction, right? Default normal, right? Project what? Project this one. Support this one. Okay? If you use normal, what happened to this one? You can preview. What is mean by normal? Normal is mean that you project this one. Oops, sorry. We project this one to this one. It's normal, this one. See, normal this one. Okay, normal to the surface of target surface, right? This one. But, okay, let's see. We have this one. The other one is if you use direction, again, projection this one. Projection this one. Along direction, let's say along set direction. Okay, set direction. Okay, so support surface this one. Okay, direction set surface. Okay, preview. See? Now it's along this surface, you see, along set direction. This means this one. That direction. Okay, a little bit different, you see? Okay. Okay, if you cancel this one, you have this one. This is allow normal, right? This one. So projection can be used in this way. Okay, you can also let's see extract. I mean, you can also extrude. If you want to extrude this one to this surface, right? Extrude this one. Normal to, it means that normal to what? This plane. Normal to this plane. Up to this one. Okay. Okay, up to this limit. Okay, you see, not this curve is normal to this surface. That one is normal to that plane. Okay, extrude normal to that plane, right? This one. See, when you extrude this one, normal to this plane. But when you projection normal to this surface, right? Different, that's why see you have different curve, you see? Right, you see? So that if exam, and you choose the wrong one. Okay? Sure. Okay. So I see up to element, up to this one, select element, this one. Have this one. Okay? You can also extrude, not up to limit. You can put dimension there as well. Okay? Okay, this one. Okay? This one. You can have this length as well. This one. Okay? See? This direction and this direction. Or you can swap this one. Right, swap this one and put this one 0 also. Okay, you have this one. See? Some like this one. Okay? Okay. Next, you see this one for extrude, right? Extrude this one. Let's see if I want to get rid of this one as well as this one. Okay, look at this one. I want to get rid of this part, this portion. Right? This one, look at this one. I want to get rid of this one. This part. And this one as well. Inside this one, right? Okay. How can we do this one? You have this very powerful command. Two command. One is trim. The other one is split. Trim and split. They are different. They are different. It seems like it's about the same, but it's different. Okay? To make sure, there's this one. Okay. If I want to keep this and keep this, right? I want to keep this and keep this. I want to get it on inside this one and as well below this, right? How can we use this one? Look at this one. You see, you have this trim. First of all, we'll try trim first, right? Trim. Come up with a standard. You see, trim. There are the trim elements. Trim is mean every element that you select can be performed like a knife, like a cutting tool. Okay? Let's say if I choose this one, and choose this one, it means that both of them can be cutting tool. Okay? Okay? So look at this one, say, if I choose this one, it means that I want to keep those side and we'll get it on this side. Okay? Okay? Look at this one, see. Select outside. You see? If you keep the portion that you choose the object. Okay? But anyway, you can switch, no problem. You can switch. You see, look at this one, you can switch. Switch side. You can switch. No problem. Is you select long location, you can switch anyway. Okay? Let's say you have this one. Add this one. One thing you have to realize, if you use string ฟังนะรับรองเลย 100% if you don't understand this you will ask the question I will not answer you if you have this one thing they combine those two into one entity they combine automatically those two into one entity okay see this is trim command this is see this one you see whole part called trim if you hide this one you hide whole thing right this one and you because this one is for only one single entity right in that case you can do fillet this one if you want to fillet you have to combine these two to do one and to fillet this one command fillet this one where is that fillet this one edge fillet this one fillet this you just select this one you see and you have this one see because it's combined to one single entity in that case you can select edge okay so trim one good thing about trim is after you trim they combine those into one single entity sometimes it's good sometimes it's not okay but you have to realize the character of the command first okay I can do the same by using split command okay now I do split what the difference this one I just delete this one delete this one right delete this trim okay now we have this one right okay now back to the base back to the original one this one entity is another entity right okay I can use split command what happened to this one I have to split this one right I do have to get rid bottom one if I get rid this one if I want to get rid this one it means that this one has to be cutting element right and this one has to be element to cut to be cut actually right see okay look at this one okay I do this one split right this one split and they are you element to cut I want to cut this one right this one I want to cut this one I select this one it means that I want to keep upper part cutting element cutting knife actually okay this one my cutting element okay okay right so we have this one if you want to change size also possible you see also possible let's say we have this one you see you have this one now you still have this one so if you hide this one you have this one you see but if you unhide this one okay next I want to get rid of this one right okay this one has to be knife right this one has to be cut element to cut right split again split element to cut
this one, right? Because I want to cut this one, right? Even to cut, I want this one to be cut, right? Cutting element means this one. Okay, so we have inside, you see. If you want to change side, you can also change side as well. Okay, this one. Okay. So now you have look the same, right? Look the same, but it's different entity. It's different entity. You see, this one is one entity, this one is another entity. In this case, you cannot use a fillet. You cannot use a fillet. Okay, you cannot use. You see, if you use a fillet, you cannot select no char. You see. Okay, you see this one. Let's see. I can select the other side. See. You see, you cannot see edge. You can find edge. See. I can try. Yeah, you cannot see. You see, you cannot find edge. You see. Okay. But if you want. If you see what it, you need to join them together. Let's say if you use this one, you need to join them. If you still want to fill it, this one, you need to join them. Join this part and this part. Okay? Now it's formed one entity, this one, right? In this case, now you can do fillet. Yeah, you can do fillet. This one, you see? Have this one, you see? Okay? So, in this case, you see, you have split, and join. Right? 3 commands in this case. Previous command, only 1 command, trim only. Okay? That's the point. But sometimes, both of these commands are very important. I mean, use a lot anyway. Modify surface, modify. You can trim surface, you can trim curve, you can trim line, whatever. Okay? You can split. Let's say I want to split this line into 2 lines. Let's say I have line, right? I want to split this one into 2 lines. I can use this one as my cutting element. Okay? In that case, you see, split in this case, we need to use split, not trim. Split element to cut this one. Cutting element, this knife. Okay? Look at this one. They will keep this one and throw away this one. Right? But if you want to switch side, you also switch side. Or if you want to keep both of them, keep both. See, if you keep both, it means that, okay, you have 2 sides here. The one here, the other one here. Right? You see? Split here. See? Use a lot. You have curve. You want to have just only one portion of curve, you can split using this split command. Okay? That's a modified curve, right? You see? And definite exam, you can have this feature, you can do this. Okay, look at this one. Okay, so you have this, right? Now you have extrude this one. You have fill. You have a fillet. You know join. You know split. You know trim. You know offset. Right? There's another command here. Interpolate. Yeah, you want to add, extend curve. You want to extend curve. Extend curve. Okay? For example, let's say I have this curve, right? I want to extend this portion, this curve to this one. I can do this one. Extrapolate. Extrapolate. Right? We're going to use H, right? There point, extrapolate point, or extrapolate H. Okay, in this case, I want to extrapolate this one, right? This point, right? This H. See? And we can extend this one, right? This one. See? Okay? You see? You can extrapolate this one or not. Okay, this one. Extrapolate. This point. This vertex. This one. You see? You can also extend line. You see? You see? Okay? You can extend this one. You see? Okay. That's another thing. You see? So you know how to do extrude, fill, right? Trim, split, offset, extrapolate, right? Fillet, right? Okay. The other one is it's about the same. Let's see. Let me put one more. I have another one. Okay, look at this one. See, you have, let's say, I have revolve, right? Revolve, same HR. You see, I have this one. If I want to do this one, I can do spy curve here. Okay, in that case, I can get up this one. I can revolve this one. You want to revolve this section, okay? 80 degree, 180 degree. You want 330, 360. Okay, so you have this. See, this one you can add thickness. This one if you want, you can add thickness. If you change this one, change. If you modify this one, okay, this one. Okay, that's similar. Okay, so we don't have group. We have only revolve. Yeah. No need for the group. Group is another way. Okay. Let's see. If I want to split this one, I can do this one. I can do this one. Okay. Let me do this one. I can draw this one. Okay, you see, and I can revolve this one, right? Revolve this surface with respect to this one. Okay, see, and if you want to have, you see, trim command here. Here, trim command here, trim. Select this one. Right, I want to keep this one as well as the bottom one inside this one. The face inside, right? This one. Let me see. Sorry, you see, you have surface here, right? This one, right? You see, Okay, I can trim this one. Trim this one. I want to keep this one as well as the inner one. Okay. You don't see anyway. That's okay. How can we do this one? Okay. Let's see. Sorry. Trim. Select this one. Select this one. Yeah. They say they cannot. In this case, they can automatically interpret. No, that's okay. You want to keep this one, right? And split this one. Okay. Element to cut this one. Cutting element this one. Okay. 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 Sketch this one. Revolve this one. Sketch this one. Revolve this one. Oh, okay. Because of they had another side as well. มันมีอีกข้างอยู่นี่นะมันเป็นนี่อยู่แล้ว Split this one. Even to cut. I want to cut this one. Cut. Oh, อันนี้มัน okay. Cutting element this one. In this case, we don't allow you to do this. Okay, that's okay. I found what happened to this one. I just extrude this one. Let's say I extrude this one. Extrude this one. Let's say you extrude this one. Both sides, right? Let's say both sides and put it in here. Okay. In this case, if you want to what? Trim. I mean split. I want to split this one. Cutting element this one. Okay. So you have this one. Right? You can hide this one. This one. Okay, actually you can do anyway. But anyway, this is okay. Okay, so one of these, okay, and the other one is multi-section. Okay, let's see. It's very powerful actually multi-section. Let's see if I use another plane offset to this one. Offset to this one, right? This one. Okay. So I do this one. Let's see, I select this one. Okay. I draw this one. Just curve. Okay, the other one as well. The other side of this one. You don't have to worry much about the number of point only. This one, let's see. Okay, you have another curve here. Okay, different number of points. This is one. And you went to multi-section this one. Multi-section, right? For this one and this one, okay? Okay, you just see the direction of curve only. Okay, and this one, see? You have this one. You can also extend if you want, right? Let's say you can extrapolate this one. extrapolate, right? Edge, this edge, this curve, right? This one. Okay, this one. Okay, so we have multi-section, right? The other one is you have grip command. You have grip command in solid, right? Grip, right? In this case, you have grip command, something like this. You have a cross section, right? And you whip this one, right, along center curve, right, with the grip command. In surface modeling, we have this one spy. We have spy curve, this one. I mean, not spy, sorry. What? Sweep. Sorry. Now we have sweep command here. It's something like a grip command, but much more powerful. Much more powerful. Let's say if you have, I have this curve. Let's see. I have this curve. I will do a curve, another curve. Let's see. Right, this one. Okay, so let's see, you have this one. Okay, and let's see if I draw profile. Right, let's see, I draw profile here. Normal to curve. Normal to this curve. Point here, right? This one, as usual, right? So this one, if we want to get this one, okay? See, if you draw another curve here, see, you want to, if grip command, this one has to be close, right? So if you grip command, you have to, this one no need, right? So you use sweep command here. Look at this one, sweep, there are a lot of them. Sweep, line sweep, circular sweep, conic sweep, there are many of them. Grip, just only this one, equivalent to this one. Okay, sweep, reference, and this one, this just the grips in solid. But it could only one command in sweep, right? This one you see profile. Which one I will? This one will be profile, right? And what? Guide curve. This one, okay? And you see that? You see default surface? No. Okay. Sorry. Sorry. This one will be this one. Okay, and this one will be this curve. Okay? Okay, and you can do this one. You have this one. The way to sweep is sweep along this surface, right? At this curve. Normal to this curve. Normal to this curve. Normal. Okay? Normal to this curve. You can change spy curve. If this one is mean that along the sweep, they just normal to this curve. If you change spy curve, it will normal to that spy curve. Okay? So this one, you have this one. You see, you have this one. See? That's sweep. Anyway, right? So you can also, let's see if I have this one. normal to curve. Let's say I have this one. Okay, let me do this one. Okay, let me put this normal to curve, this one, this curve at this point. This point, right? Okay. I can draw this one. Use it plane. Origin. Use this projection, this point, right? This one. Okay, you can, if you have curve here. Okay, let's see, you have this one. Okay. Actually, when you do sprite curve here, I mean, sweep curve here, either one can be, you see, if I choose my profile will be here, right? My center curve, guide curve will be here. We have this one, right? But you can do another way. I can use my profile and this my guide curve. Okay? Should be my profile. I choose it my profile. This is my guide curve. See? You have this. See? They said cell intersection. You see? It's cell intersection in this case. Right? You see? If you choose this one. See? This is my profile. This is my. You see? This is my guide curve. Along this one, because you have this one very like curve like this one, right? In that case, if you change a little bit this one, more than I mean, just above this one. Let me delete this one. Make a little bit less slope. In this case, you can do this one. Profile, this one, this one. Either. See, either one can be profile and guide curve depending on your objection or your objective. Okay, this is the only one command in sweep. Actually, there are a lot anyway. I will cover that one later on. Okay, now try it. Now you should try this one. Let's say if I want to create this one, Okay. First of all, you try some of those commands first. Try to some example by yourself. Some of those commands that I just give to you. Okay. And those commands that I just give to you is enough to do this one. It's enough to do this one. Okay? So try it anyway. do these two examples. You have to submit today. This one and the other one. Okay? And this one. See, you have to do this both of this. So อย่าคุยกันเยอะเร็วถ้าไม่ทำแล้วคุณไม่ทำเดี๋ยวจะทำงาน